Hello, in this video, we're going to be talking about calculations involving pH, pOH, concentration of hydronium ion and hydroxide ion. And before we start, I would like to mention some of the formulas that are very important. So for pH, you calculate pH using pH equals negative log of hydronium ion. And hydronium ion here would represent any acid, okay? Then we go to pOH. Now pOH would be negative log of OH minus. OH minus here would represent hydroxides, that is the base, okay? Why this one on top here represents acid, this one represents the bases. Okay, so how do we calculate for pH or pOH when we are given one of them? So we have pH plus pOH to be equals to 14. Therefore, we can calculate either of these using this formula. So I can get pH from pOH by saying 14 minus pOH. I can equally get the pOH by saying 14 minus pH, okay? Then the next equations that is of importance is, what if you're given the pH and you're asked to find the concentration of the acid, okay? So you can use this H3O plus equals to 10 raised to power, that's antilog of pH, so 10 raised to power negative pH. So this is the equation to solve for concentration when the pH is known. You can also find the concentration of the base by saying 10 raised to power negative pOH. Okay, so having known these equations, let's solve some problems. So in this question, you are asked, what is the pH of HCN solution with a concentration of 0.000025 molar. Now, this molar is molarity, and that is mole per liter, okay? So what you do is, we're looking for pH and we're given the concentration of the acid, so we just go ahead and do pH equals negative log of H3O plus. Now, in this case, this is representing the HCN solution, okay? So all we just need to do is to negative log into 0.000025 molar. And this is going to give us, if we punch this into the calculator, it's going to give us 4.6, okay? And that is it, that is the pH of that solution. Now, in this one, we're asked to find the pH of a base concentration of 1.75 times 10 raised to power negative 2 molar. Now, note something. This is asking for the pH of a base, which means that we cannot go ahead to calculate the pH using this. This is the concentration of the basic solution and not that of acid. So in order to solve for this, the first step would be to look for the pOH of this base. And we do this pOH equals negative log of 1.75 times 10 raised to power negative 2. Okay, now this is going to give us 1.76. So now that we have the pOH, we can then go ahead and use pH equals 14 minus pOH. And since we know our pOH to be 1.76, I'm just going to say 14 minus 1.76. Therefore, my pH of this solution is going to be 14 minus 1.76. And that is going to give us 12.24. And this makes sense because this is a base, and of course, using the pH scale of 1 to 14, Down from 7, which is the neutral point, down to 1 is acidic, while from 7 down to 14 is basic, right? So if the pH is 12.24, this tells us that it's a basic solution, which makes sense because this is a base, right? Okay, now the next example is this. It says, what is the pH, pOH, and hydronium ion concentration of a basic solution with a concentration of 0.0289 molar? So we also have basic solution here, which means that we cannot start calculating with pH because what we have is a basic solution. And the relationship with a basic solution would have to do with pOH. So in this case, we start with solving for the pOH, which is pOH equals negative log of 0.0289, okay, which is, if we put the formula, that would be log of OH, right? So this is the concentration of the basic solution. So that is it here. Now, when we solve for this, we are going to be having 1.539, okay? So now we have 1.539. We go ahead to solve for the pH. So the pH is going to be pH equals 14 minus this value, 1.5. I'm going to approximate this to 1.54, okay? So 1.54. And this is going to give me 12.46. So that will be the pH of the solution. Now, we solve for pH, we solve for pOH. The next thing would be to solve for this. Now, for the concentration of the hydronium ion, we have the relationship between pH and that. So we just go ahead and make use of H3O plus. It's going to give us 10 raised to power negative pH, okay? Therefore, 10 would be raised to power negative 12.46. And that is going to give us 3.47 times 10 raised to power negative 13 molarity. Okay, so that gives us our hydronium ion concentration. All right, so we keep going. For this next one, we have what is the pOH, the OH concentration, and the H3O plus concentration of a basic solution with a pH of 9.76. Okay. So they gave us the pH to be 9.76, and you're asked to calculate the pOH, the OH, and the H3O plus. Now, using the relationship between the pH and pOH, we can first calculate the pOH using pOH equals 14 minus pH, right? Therefore, our pH is 9.7, so I'm just going to put it here, minus 9.76, and that is going to give me 4.24, okay? Now I've calculated the pOH. Now let's go ahead and calculate the hydronium ion. So H3O plus is equals to 10 raised to power negative pH, right? So if my pH is 9.76, I'm going to say 10 raised to power 9.76. If we do this calculation, my hydronium ion concentration is going to be equals to 1.74 times 10 raised to power negative 10. Okay, and of course, this is concentration. You put your unit molar. Now, let's go ahead and solve for the hydroxide ion concentration. And this here has to go with pOH. So what I will have here would be 10 raised to power negative pOH. Therefore, I'll have 10 raised to power negative 4.24. This is going to give me 0.0000575, which I can as well turn to scientific notation, which is 5.75 times 10 raised to power negative 5 molar. Okay, so that would be the concentration of the hydroxide ion.